So today I want to introduce you to algebra. So you've been dealing with algebra before, sometimes even without knowing it. I'm sure in your whether be it your high school or so, and you probably came across a formula. Have you ever seen this formula? Uh, Perimeter equal to half times the length plus the width. And that's if you have a little rectangle and uh, maybe this is the length, this is the width. And you want to know the distance around, which is what we refer to as the perimeter. You have a little formula, right? Now, what you see happening here? You see L and W. I should start with P, L, and W, right? So what's happening really is that we have a general formula for the perimeter. That once you know the length and the width of the rectangle, you insert those here, and there's a term we use in algebra. We say you substitute in the formula, and that will produce the perimeter P, right? Perimeter P will change based on the length and the width of the rectangle. What you're seeing here, you're seeing a formula that makes use of letters or symbols to represent quantities, right? And that is basically, what algebra is about. We allow symbols or letters to be used to represent numbers, and we make generalization about the properties and so of what we call algebraic expressions. This is an algebraic expression. It's an equation, it's a formula, right? You probably know another one. Like if you have the same rectangle, the area of the rectangle, we say it's length multiplied by width. So here the A, it's not like the A as in, some word, but it represents the area. L represents the length of the rectangle. W represents the width of the rectangle, right? And if you were to be given, let's say L, given L equals to, let's say, 10 centimeters, and W equal to 5 centimeters. And you were to ask, you were asked to find A, right, which is the area. Find the area of the rectangle. What you do, you will use this formula. A equal 10 cm multiplied by 5 cm equals to 50 cm squared, because that's the unit you express area in, right? I mean, when the length and the width are in cm, right? But what you actually did there was substitute 10 cm for L and 5 cm for width. And you now can calculate the area of the rectangle. And that's a simple algebraic operation, substitution. You do it all the time. You do it when you're given a formula and you're given certain dimensions or other. It doesn't have to be dimensions. Formulas can involve lots of things. But the point is, or the bottom line is, when we make use of symbols or, well, more narrowly, letters, because that's what we do mostly. We're not going to get into very complex symbols to represent, real numbers. Well, we are venturing into the study of algebra. And these are two good examples of two formulas that you probably know from primary school. And they're really algebraic formulas that they involve. You don't see a number alone inside, right? I mean, this one has a number here, this one here. But you also see letters or symbols which represents real numbers, right? There's another famous thing that that you do sometimes in high school called binary operation. Binary operation. And it really involves some algebra, right? Where we substitute in expressions. For example, if we say the binary between A and B, and you usually put like a star, it could be a lot of other symbols, plus sign. So the binary between A and B is equal to, let's just say, right? The square root of A squared plus B squared. Right? What I mean, whatever A is and whatever B is, you substitute them where A and B here and calculate the value. So if you were to ask, find 4 asterisk 5. So 4 asterisk 5 would be equal to the square root of 4 squared plus 5 squared. You know what? I should use a nice number. Let me use a nice number. Use 3 here. 3, 3, 3. So use 3. So you have, what is this? Yeah. It's equal to then the square root of 25, which is equal to 5. All right, that's what you call a binary operation. Let's take another one, maybe. You're following so far?
Sorry, complete over back the
Yes, sir. Yes,
sorry,
sir.
complete over back the square root part. I didn't catch it on too fast.
This part here?
Yes, sir, please.
Yeah, 4 squared is 16, 3 squared is 9, you add it to your 25. Square root of 25 is 5. What's puzzling you?
Okay, sir. No, I thought it was a 5, just now it is 3.
3, yeah. I changed it 5, was a 5. I changed it to a 3. Because 5 would have given you a horrible number. I didn't want a horrible number as your answer. Let's go with another. The binary between, let's say, P and Q, right? Binary between P and Q is equals to P squared minus Q squared. The square root of that, right? So they define it that way. The binary between P and Q is equals to the square root of P squared minus Q squared. So they ask you, let's say they ask you to find find 4 you might end up with a horrible let's go with that. 4*3, or the binary between 4 and 3. So that would mean, okay, 4*3 is equals to the square root of 4 square minus 3 square. You get 16 minus 9 is how much? 7, square root of 7, right? If you want to write that as a decimal, it's okay, but you can stop here. This is something we call a surd. You don't have to know this for the course, but when we have the square root of a number that is not exact, you know, like the square root of 25, like we had in the previous problem, we could find an exact value, right? It's 5. But the square root of 7, if you were to punch it in your calculator, it's a non-terminating decimal. So instead of writing with, you know, with so many decimals behind there, you can't write out all of them anyway. We leave it as root 7, right? But this is not covered in this course. Good. So what you find happening here, you're actually substituting numbers in the place of symbols, right? So that's an algebraic operation you must be able to do, right? Because your life might very well be full of formulas, right? It might be full of formulas. For example, let me give you an example, all right? Let's say, okay, you invest some money, right? You invest some money. Let's say you invest, I should, let me phrase this like a, a man invests. I should put invests because this is singular. Let's see, all right. $1 million in the bank for 1 year, at, let's just say 2% compound interest, you know? Compound interest. Full stop, right? So let's get a question in here. How much money this is a he, will have at the end of the year, right? 1 year. The year is 1 year, right? And that's a question. So maybe you do a little bit of research and there's a formula that the amount of money that will accrue or accumulate when you invest money, compound interest is given by this formula. P bracket 1 plus R over 100 to the n power, where P, or if you want to give, let's say A is the amount accumulating. I'll use the word accumulating, right? P is the amount invested. R is the rate, right? The interest rate of interest. And N is the time in years, right? There are a lot of formulas where the time is not years and all of that. We're keeping it simple. So all we need to do now is use this formula and calculate A, how much accumulate after a year. So you put in your 1 million there, bracket, 1 plus 2 over 100. That's the first power, right? So you don't have to do anything with that. Equal to, so is anybody helping me here? So this will be equal to $1 million. Multiply by this whole part here, right? Remember? There's a multiplication sign there, even though we don't know how to write it, but I put it now. And remember, we work out what's in the bracket, so that's what? 1.02. But raising it to the fourth power is the same thing, right? So it's what? Are you working it out? What's the answer you get? Huh?
Type it out.
$1,020,000.
Type it out. Yeah.
$1,020,000.
1,020,000, right? That's right. Huh?
Yes, sir.
So you actually earn how much in interest? Can you look at the figure and tell me?
20,000.
20,000, right? So if you were to invest $1 million for 1 year in a bank that pays 2% interest, right? Few banks ever give you that. They give you about 1%, right? Less than 1% to. If you put this money fixed deposit, you may have a little more than 2%. But most banks in this country for saving account, you barely get you don't get up to 1%. You don't get. So let me ask you a question. Is that a good investment?
No, sir.
Huh?
So I think it depends on how you look at it.
Okay, nice answer. So look at it some way and tell me if it's a good or bad investment.
Sir,
I like that.
for me personally, like say that I'm in a person where I'm in a position, right? I lose my job or something. I have this fixed account or this we call it investment now. I could go back on it if anything. It's like a safe space to me. It's like an emergency money. That's how I see it.
Okay.
And like for people who get money, it mightn't be the much, but it's still something at the end of the day, you know.
All right. Any other thoughts?
Sir, it's like to me it look like it's not much within a year. Like it's not much, but like depends on how much interest you paid. It's gonna be like the back feed of how much you're getting end of the year. But in this case, yeah, 20,000. As she speak that you're not a working person and you're saving up this. To me, it's like a half and half working out thing.
All right. Somebody wants to say something here.
Sir, as for me, I don't really see it as a good investment because most banks in Guyana, for example, them War Bank, they only give you they give you 0.5% interest on saving account. So it's not like you're gonna go back and get a big interest. It's just like actually like a 5,000 more per year. So it's not like a good investment for me.
Very good. I like these thoughts. Y'all are thinking. Very good. Yeah, well, think about it. Somebody, I like how the discussion start. Somebody said it depends. And I'll tell you why that's a good answer. If you are a young person, right? And let's say, all right, somebody give you $1 million to, do something with it. If you were to invest in something as simple as, let me say, mine some fowl, chicken, white fowl, right? So if you spend, and first of all, if you get $1 million, my advice to you is not to spend $1 million, the total investment on one thing, right? I mean, we're deviating from our class, right? But I'm just saying, if you have $1 million, you don't spend $1 million on and invest it like that on one thing. Because let's say you get into chickens, you want to buy some fowls, the white fowl. And you invest 1 million, guess what? There's a bad batch of eggs. And the fowl, they ain't grow good, and so you might very well lose most of that money. Right?
Sir, and it's like you losing feed money because you got to keep supplying the chicken with feed and grower and then other stuff. So it's like you're not making nothing on it.
Yeah, and that's what I'm saying. Sometimes you invest I don't mean you buy 1 million chicken. You take $1 million, you buy feed, you buy the chicken and so, but the chicken doesn't grow. You understand? So you never invest all your money. As I said long ago, we used to say, don't put all the eggs in one basket. Right? You're a big business. People say you must have a diversified portfolio, meaning don't invest in one thing. Right? Maybe invest in 2, 3 different things. Right? Maybe you invest in some ducks. Right? Invest in some ducks. And maybe invest also in some, white fowl. Yeah. All right. Or you can invest in, all right, let's say some layers. I'm just using some wild thing, right? If poultry is your passion. So you divide into 3. All 3 of these things can feel something wrong. The white fowl might come good, or the white fowl come good, but the ducks, something wrong with them. So you get white fowl and layers come good. Right? All 3 can go wrong. That means something you're doing wrong, totally wrong. Right? And indeed, let me just say, invest it in one of these things, white fowl. You check. If you were to invest, let me say about 1/3 of this money, 300,000. Let me put it like this, in white fowl, right? What the return on white fowl is about 50%. 50%. So you could make. Think about it. I usually look at it like this. I used to, as a matter of fact, I was a broiler farmer not long ago. For every 10 chickens that you mind, right? 10 chickens, you need about a bag of feed. 10 chickens. I'm just using 10, right? You need about 1 bag feed. 1 bag feed. 10 chickens, let's say it's about $2,000 now, right? 1 bag feed is about, let me say 6,500. I always say 7,000. So you get $9,000. You invest, right? I didn't include here labor and some miscellaneous stuff because you got to go and get, some shaving and water and maybe some medication and so. So let's say you spent about $10,000. $10,000 on the chicken. If you sell 10 chickens today, how much you think you will get? With what you know of chicken price. And let's say your chickens grow to about 5 pound meat you get for each chicken. 5 pound. 4 chicken, right? 4 chicken. Anybody knows the price of chicken today? Chicken meat?
$400 a pound, I guess.
I'm like 600 a pound now. It raised very high.
Oh, really?
400 is too cheap.
$500.
500 a pound, sir. 5 something, like
Yeah,
560.
560.
Let me go
560.
at 500. Let me go at 500. So one chicken, then you're gonna get $2,500. And then you get 10 of them, right? And you're hoping that all 10 come up. You might lose one. Let me go with 9. Let me say 1 there. How much you make there? 2,500 by 9.
22,500.
52 what?
22,500.
22,500.
22,500, sir.
Oh, 22.
Yes.
So you spend 10,000 and you make 22. Forget this 500, 22,000, right? So you made a profit of $12,000 for every 10 chicken. See what I'm saying? See that? So only 10 chicken and you don't make $12,000. If you go with 20 chicken, you don't make what the bank's supposed to give you for the whole year. So you will invest such a small amount of money. You invest, forget the 12. Let me say you make only 10,000 from it. 10,000. What am I saying? Yeah, right? For all the other things. For every 10 chicken you make, you can make $10,000. So if you have the energy, you have the time, if you're jobless or what, mining chicken, poultry makes better sense than putting money in the bank. However, I like the girl who said it depends. This carry a lot of risk, right? Of course, you have to be young and strong. You have to have the time. You have to give attention to these things, right? What would happen if you take out labor costs from this money that you make, the 10,000? Well, you haven't made anything. So if you're doing something else and maybe it just takes a few minutes in the morning or the evening to feed the chickens, it's all right. But if this is your bread and butter, you haven't made anything. And an old person may not be able to do this because, to go and feed chicken and whatever, you might be able to, in the bank, you put the money and you forget it. And you go at the end of the year, you collect your 20,000, right? Low risk, no effort into it really. Just carry the money to the bank and you collect back 20,000. But this calls for a lot of work, right? A lot of time, high risk, but the reward is high. That's the nature of business. Anyway, that's not part of our lesson. What I was getting at is the use of a formula. What we're basically doing here is algebra, right? We are substituting values, real numbers, for symbols in a form. That's what algebra is all about, right? That's what algebra is all about. So one of the things we want to get into is how do we manipulate algebraic expression, right? How will we do that? So let's say, all right, you have an algebraic expression, and an algebraic expression, I explained to you, could very well be a set of symbols that represent real numbers, right? So, okay, let's just say you have 2a plus b okay, plus 3a minus 4b. Look at this. So this is an algebraic expression. However, this is not one that is in its simplest form. We can actually simplify this. We can simplify it, right? Simplify it. And when we are simplifying algebraic expression, we can only, well, in this case, this one involves just addition and subtraction, right? It just involves addition and subtraction. So what you need to do now is you need to simplify it, Now, when you're simplifying algebraic expressions that involve addition and subtraction, only those that are similar you can add and subtract. When we say similar, what do we mean? You see an A here, but down here is a B. Would you say they are similar?
No, you group in you like
No,
term.
sir.
No, sir.
No, they aren't similar. They have another A, they have another B. No, they're not similar. A and B are two different letters. However, you have an A here and an A here. You have a B here and you have a B here. And somebody said in the background there just now, group them together. You don't have to group them if you have the mental aptitude to watch it and do the operation, all well and good. For those of us who can't watch it and simplify, the suggestion that person gave is correct, right? Group them together. So 2A and 3A, you can write that together. 2A plus 3A. Then you have plus B minus 4B, right? So now you can simplify it. 2A and 3A will be 5A. Right? That's like 2 apples plus 3 apples equal 5 apples. That's what I mean, right? So you have a B here and a minus 4B, right?
Negative
So
3.
you can think of this as 1, right? 1B, even though we don't normally write the 1. So 1B minus 4B will give us minus
Negative
3B, right? And this here is the simplest form, right? Simplest form. Let's take a couple more examples. Let's say you're asked to simplify PQ plus AB minus 2PQ plus C. So you see anything similar there?
Yes, sir.
Yes, sir. PQ.
You see, there's nothing we can do with the A, B, nor the C, but we seem to be able to do something here. So PQ, all right, you want to put them together? PQ minus 2PQ plus AB plus C. So we can work this out and you get 1PQ minus 2PQ give you minus PQ. No need to write 1, right? 1PQ. Just write minus PQ plus AB plus C. Some textbooks, because they don't like a negative sign sticking out there, you can see them do this. AB plus C minus PQ. Put that at the end. You can put it in the middle too. You can have it as AB minus PQ plus C. No problem. You're looking for similar terms, right? You're looking for similar terms. Let's do another. Let's say you're asked to simplify. What are you seeing there? Anything similar?
Yes, sir.
Yes, sir.
Yeah, we're seeing some a square b, and we're seeing some ab squared, right? So we can take this one and this one, put it together. We're seeing this one and this one looking similar. And then this one is a little different, so you put it at the end there, no problem. So these two becomes 2ab, sorry, 2a squared b plus 2ab squared minus a. Now, this can be simplified even further, but because you are not there yet, we will consider this as the simplest form, right? You are not there where we can simplify it even further. We're going to get there eventually. Good. So all of these, you notice all the examples so far involve addition, subtraction, addition, subtraction. That's all.
Excuse me, sir.
Huh?
Excuse me. The A isn't supposed to be a square because I see you put A at the end. It isn't supposed to have a square at the top.
Oh, yeah, this one has a square, no? Very good.
Yes, sir, a square.
Yeah, great.
Before you move on, right?
Yeah.
When we are adding the a square, how come? I know in front of the a we'll have 1, right? So when you're adding the powers, when you just put back the a with the power?
Yeah, you don't trouble those. We're not multiplying anything, so you don't trouble the powers. This is
Okay.
like 1 and 1, you add them, and that's it. You're 2. You get 2.
Okay.
1 and 1, you add again 2. You don't trouble this at all. Don't trouble it at all.
All right.
We're coming now to multiplication and division, and then is when powers can change. Right? Let's try that. So we're going to a little bit of multiplication and division. We just dealt with addition and subtraction, right? Good. So we done with this. Let's go this way. So let's say you have x multiplied by y multiplied by z. Let's go with plus a multiplied by b. Now, while we couldn't add a and x and y, or y and z, nor could we add a and b, but we can multiply them, right? We can multiply them. So these three you can write as x, y, z. Drop out all the multiplications and write it like that. Plus ab. Right? You could drop out the multiplication sign and write it like that. But because x, y, z, and ab are very different, we can't add them. We can't add them. You know, I mean, we're adding them there, but we can't write it simpler than that. You know, we can't add it. They are being added there, but we can't write it in a simpler form. We have to leave it like that. Let's try another one. So let's give it x multiplied by x multiplied by y minus x.
You want to show me abs?
X multiplied by x.
Your abs, when it's like in peace, we would say scrubbing boards. That's why the lady scrubbing boards.
Could you mute yourself? So this here, we will get x squared because x multiplied by x times y, so you get x squared y minus x by x by x, you get x cubed.
Big.
So as I said, you could simplify this some more, but as of now, we will leave it like that. Right? Notice we can't simplify this further where we can like maybe take away this x cubed from this here and get something simpler. No, because they're very different. This one has a cube in it, this one has a square in it. So we can only leave it like that. There's something else we can do, which later on we call factorization. We come into that. We come into that. Cool. Let's do something that involves division. So let's say you have a square b divided by AB. They look very different, so you can't add them, you can't subtract them. However,
Multiply.
you can divide them. So what you can do is do this. Write out a square b as this. A multiplied by A multiplied by B. Right? That's the same as a squared b. Divided by A multiplied by B. And just like you would cancel fraction, A into A, 1, A into this is 1, right? So there's nothing else that would match up with this A, but there's something that will match up with this B down here. So B into B, 1, B into this B is 1, right? So what do we end up with? So 1 by A by 1 will give us A, over 1 by 1 is 1. So our answer is A.
A.
So you see, in this case, the B disappeared. The B was canceled out.
Excuse me, sir.
Mm-hmm.
I understand the addition, multiplication, and division, but for the subtraction, I cannot like catch it on that fast. Is it okay if we can go over it?
Subtraction?
Yeah, the previous sum we had 2a plus b plus 3a subtract 4b.
What is it? 2A?
The previous sum we had on subtraction, which was 2a plus b plus 3a subtract 4b.
You had one like that?
Yeah, this one will you give us.
Yeah, we said we're grouping the like terms together, right? So the 2A and the 3A, you put it here, 2A plus 3A plus B minus 4B, right? The 2A and 3A is 5A. B minus 4B is like 1B minus 4B is minus 3B. I think the negative, this negative is what is puzzling you. 1 minus 4 is not.
Yeah, but the negative
Minus,
make me corrupt like.
yeah, you got to get familiar with it by doing plenty of them. Right? You have to do a lot of exercises until it becomes second nature. It was easy when I said like, okay, 2 apples plus 3 apples is 5 apples. But this one is a little hard. Let me say it's bananas. If you have 1 banana, but you owe somebody 4 bananas, you are short by 3 bananas, not so? You got 1 banana, well, I say you owe me 4. Right? How much you owe the man really? You can give the man the 1, but how much will you be owing? You'll be owing 3. So that's minus 3b. Think of it like that.
Yes, sir, I catch it now.
And if you're not certain, forget the letters and just put 1 minus 4 and you'll get -3. And don't forget to stick in the b. Let's do another division. So we got like, okay, 4x squared y cubed divided by 2x y squared. Look at that. Some people can watch this and tell the answer, right? But if you can't watch it, you might have to write it out like this. 4 multiplied by x multiplied by x. Right? That's what x squared is. X squared means x multiplied by x. Multiply y cubed is y multiplied by y multiplied by y. All over 2, that's this 2 here, multiplied by x multiplied by y multiplied by y. Right? Y by y is this y squared. And now we can cancel as much as we could. Y, 2 into 2 is 1, 2 into 4 is 2, okay. X into x is 1, x into this x is 1, okay. There are no more x's, so you go to the y's now. Y into y1, y into y1. This y into y is 1, y into y is 1, you know? And then you simplify now. 2 multiplied by, well, the 1 is in 2, multiplied by x, multiplied by this y at the end here, so you get 2xy, and the whole bottom is canceled out, you get 1. So your answer is 2xy.
Sir, is it possible for the numerator to be lesser than the denominator in any of these sums?
Yeah, anything can happen. Anything, man.
You could show us one with that, please.
You want the numerator to be less than the denominator?
Lesser than the denominator, yes.
Let me go with something. Let's go with 4x cubed y divided by, let me go with 12x y squared. Let's go with that. Right? Write that out, you get 4 by x by x by x by y divided by 12 by x by y by y, right? So 4 1s, 4 3s, this x and this x will go. There are no more x's at the bottom, so you have y and y can go. All right, so let's simplify it. So 1 by x by x, you get x squared over 3 by y, 3y. Right? So the numerator is less than the denominator.
And that's it?
Yeah.
Okay, great. Thank you.
Good. So that's a nice little introduction to, the addition, the subtraction, the multiplication, and the division of algebraic expression. And mind you, this can get very, very complex, right? So what about if they involve fractions now? Let's see some algebraic fraction. Let's talk a little about this. Algebraic fraction. Right? Let's say you have something like this. X over 3 plus x over 5. I want to put a 2 there and so no problem. Put a 2 and so 2x over 5. And you have to simplify this. Don't be scared. You treat it just like you treat fractions, right? Find your LCM, you get 15. 3 into 15 is 5. 5 times x is 5x. Right? Plus 5 into 15 is 3. 3 times 2x will give you 6x. Right? So you end up with, what's that? 11x over 15.
Sir, can give us one to do?
Wanna try one? Do one that involves subtraction. Let's go with 3y over 4 minus y over, let me go with 3. Try this.
Five y over 12.
You get y over 12, or let's try
No,
it.
5y, sir. 5y over 12.
We get our LCM of 4 and 3 is 12. 4 into 12 is 3. 3 times 3y will give us 9y.
9y.
Right? 3 into 12 is 4. Oh, put a minus sign here for us. 3 into 12 is 4. 4 times y is 4y. Right? So what did we get? 9y
5.
is 4y is 5y over 12.
Sir, we get any multiplication with that too?
Yes, we'll get to that just now. So you add a little fraction, algebraic expression with fraction. Here you do a little bit of subtraction.
Excuse me, sir, can you go over it one more time, please?
This one.
Yeah.
So just like you would do any fraction, you find the LCM of the two denominators, 4 and 3, it's 12. Right? And what do you normally, you take the denominator here, 4, you divide 12 by it, right? So 4 to 12 is 3. You multiply that by the numerator here, 3y. So 3 by 3y gives you 9y. All right, so if you're not certain of that, then write down it like this. 3 multiplied by 3y. All right, 3 multiplied by 3 is 9. And you put back the y. All right? That's how we get 9y. 3 into 12 is 4. 4 times this y is 4y. And then you do the subtraction on top. 9y minus 4y gives you 5y. Put back the denominator, 12. And that's it.
All right, thank you.
And of course, you can get more than two expressions, you know. Let me show you. You can have something like this. Watch. 3y over 4 plus y over 6 minus 2y over 3. Look at that. Looks horrible, right? But you don't have to be scared. You do a normal thing as though you were adding and subtracting fractions. Your LCM is same 12. 4 into 12 is 3. 3 times y will give you 9y. Okay. You put back the plus sign. 6 into 12 is 2. 2 times this y is 2y. Minus 3 into 12 is 4. 4 times this 2y is 8y. Right? So let's simplify. 9y plus 2y will give us 11y. 11y minus 8y will give us 3y all over 12.
Sir, we can break it down. Like,
yes, we could. Yes, that's the next step. Yeah, you could. You could now cancel this 3 and this 12 and you get 4. Yeah, you can do that. And you end up with y over 4. I like how y'all are involved with the class. You know, that's very good.
Third question. So if you should leave your answer at 3y over 12, would you still get your marks?
Well,
Rather
that
than
depends. If you were doing it, let's say I give you to do, and you have to write out the answer, you stop here. Maybe if the question gives you maybe, let's say 3 marks, you may lose a mark for not simplifying here. Right? However, if I give you a multiple choice, right? I tell you simplify this and I give you A, B, you know, you get these answers, C, D, and none of the answer is 3y over 12. You're looking for this, but you ain't see none of them like that. But here's an answer, y over 4 here. You got to know that you got to break it down to this. If you don't know, you might choose the wrong one.
sir, unless if you're working it like in a paper 2 and it says simplify your answer, then like y4 is the correct answer for that question.
Y over 4, yes. But as I said, if I give you a multiple choice test and I put the answers y over 4, you might not see that. You might say, man, I work this thing, I get 3y over 12. But a man get no answer like that. Well, you have to see, like somebody asked the question, could be simplified down. They saw that 3 and 12 can be canceled down further, which was good. That's a funny thing with multiple choice, you know. You either get it right or wrong. Or with essay questions, or if you want short answer, you might try something and you get the right answer, but you get a step or 2 right. And you get a mark or 2. You know, so yeah, they have their advantages and disadvantages. And somebody asked the question about.
Yes, so before you move in, right? So even though the 12 doesn't have like a letter attached to it, it is wise that you could break down the numbers as long as they can break down.
Yes, yes, yes. Those are all good questions, yeah. Good questions. Yeah, you could.
Sir, in this case, division is implied or not?
Yeah, well, that's it. In this part here, 3y over 12, yeah, you can do some cancellation. Yeah. So we start out with a problem that just add addition and subtraction. But here it is, a little bit of division comes in at the end there. Yeah, these things can take turns in. And when it comes to multiplication and division, so let's say you have 2a multiplied by 3bc divided by a squared. Let's say something like that. Right? So, as we said with the order of arithmetic operation, you can do them in the order in which they appear, right? So we can do the multiplication So you get 2 multiplied by, let's say A multiplied by 3, multiplied by B, multiplied by C, all over. So this line here is like you're dividing, right? Divided by A multiplied by A, right? So one of the A's can cancel with one of these A's. Nothing else can cancel. And we get 2 multiplied by this 3, 6. B multiplied by C is B, C over A. And that's
So in this case, right, as if was instead it had a B, C, and it had a A, right? It could have canceled, or it should have remained the same.
yeah, if there was another, like go here, it was 3AB.
Yeah.
Yeah, you could have canceled the other A, yeah.
Okay.
Unfortunately, this one was my there. Let's take another. Let's go in order. 4A square B multiplied by, no, let me put a division sign here. Divided by 2AB multiplied by A square B square. Look at this one. Right? So as we said, you can do it do 2 different ways. You could take this piece, do your division first, and then multiply by 1, right? So we can do that for A multiplied, sorry, 4 multiplied by A multiplied by another A by B over 2 multiplied by A multiplied by B. Then you finish it off, then multiply by A. Multiply by A, multiply by B, multiply by B, right? You can do it like that. And let's see if we can cancel. So 2 1s, 2 2s, A, 1, okay. No more A's, all right. This B, What is left? We're left with 2 times A times A times A, that's 2A cubed, right? Times B squared, right? Because B by B here, so you have B squared all over 1. So your answer becomes 2A cubed B squared.
So I can go over back the part where we got A times B times B. I don't understand how you come up with that.
Yeah, watch. 2 by this A. What is A? 2A, right? That's 2A. 2A by another A will be 2A squared. Multiply by another A now will be 2A cubed, right? Because you have 3 A's. A by A by A, it will be A cubed, right? So 2 multiplied by A multiplied by A multiplied by A is 2A cubed. That's 3 A's you multiply. The B by the B, well, that's it here. And you can actually write this whole expression over 1 if you know, you're confused.
Sir, so if it had like a remaining number at the bottom or a letter, you could have multiplied it by the 1 also and put it at the bottom of what you got.
Yes. If you had some, let's say 3 at the bottom here, you would have put a 3 here, and then you would put a, stroke there, I put a 3 at the bottom. Yeah. So that's a nice little introduction you got there to algebraic expressions, adding, subtracting, multiplying, dividing. Let me see, did I lose track of? Now I think These were not examples that were fractions. I think I lost track there. Let's go with fractions. Let's go with fractions. I think I lost track of what we were doing. So let's go. And let's say we have 2a squared b over 3xy multiply by, let's go with 4xy squared over ab. Look at that. Right? So by now you could have picked up, instead of writing the thing out the long way, you could have seen that, okay, you know what, we can cancel this a with one of these a and get an a here, right? This x can be canceled with this x. This y can be canceled with one of these y's and get y. Anything else we can cancel?
The
I don't
B's here.
The B, sir.
The B.
Oh, yes, there's a b here and there's a b there. Very good. So we end up with 2a times 4 times y. So the 2 by the 4 is 8. A by the y is a y over everything else is canceled out on there except the 3. We put back the 3. All right, so you have to be careful because sometimes you miss things like I did.
Sir,
Yeah.
if in this case, right, we had division sign, we just flip over the denominator and the second fraction and do the cancellation as we do the multiplication one.
Very good. Yeah, that's it. That's it. Yeah. Yeah. So if you were to, let's say we try one of that. So you have, all right, 4e b cubed over 3x squared y divided by 2ab over xy, right? So as you rightly said, flip over ab cubed over 3x squared y multiply by, flip this over, xy over 2ab, right? And you can do our cancellation. Okay, yeah,
2 into 4,
2, yeah. This
AB can come out.
this a, this b, and
Then
2
the
of
Y can come out.
that, so you end up with b squared. Y
Then
is
you
your,
had a
yeah.
1.
And then
And the
x
x
squared.
squared, the x squared will be equal to the,
So you end up with 2b squared over 3a.
Excuse me, sir, I got a question.
You said you have a question?
So the AB, it's like two separate letters. It's not like together.
Where? This here? Here?
Hello? Yeah, the AB.
Yes.
It's two separate
Two
letters.
multiplied
It's
by
not
A
together.
multiplied by B. It's the same like you have here. 4AB, 4AB cubed. They all multiply one another. It means 4AB cubed is 4 multiplied by A multiplied by B cubed. 2AB means 2 multiplied by A multiplied by B. You don't normally write the multiplication sign. You just drop it out. I'm happy that people are asking questions, you know, because people sometimes they get scared of algebra. There's nothing to be scared about. Right? There's nothing to be scared about. As you can see, y'all are correcting me. Y'all are seeing better than me, which is very good. I am missing letters and powers and so what y'all are seeing, and that's good. Good. So let's move on to something else. And one last thing now. And that has to do with something called, before I go to that, well, in the outline, they talk about something called factorization. Factorization. Right? And what this means basically is that, okay, remember earlier we simplified stuff, and we might end up with something like this. A square B plus AB, let's say ABC. And we say, man, these two things are different. They can't be simplified any further. Because here you have a power. This one just has A. B is the same, yes. But then there is a C attached here that prevents us from doing anything more. However, we can do one more thing. We can do what we call factorization. Right? And what factorization is this. You're looking for common factors. So we see an A here and an A here. This one has a power, this one doesn't. We have a B here and we have a B here, but there's no C in both terms, right? Each one of these is called a term. This is a term and this is a term, right? So there's a C here, but there's no C there. But we see it like A is common and B is common. So what we can do, we can pull that to the front and we can have A and B because that's common, right? We're not saying A square is common. We're saying A is common. The reason why we're saying A square is not common because this term here doesn't have an A square, it just has an A, right? So we don't want to say A square is common. A is common. So we pull that to the front, and then B is also common. So we pull that to the front. We put a bracket here, and I'll show you where all of this came from just now. So A square B divided by AB. Well, sometimes it's hard for you to do that. So you can write it to one side. A square B divided by AB will be, the B's are going to cancel. A and the A square, you left with A. So you put A inside here. Plus ABC divided by AB will give you just C. Right? And if you don't know how to do that, take ABC divided by AB. The A and the B will cancel out, right? I'm taking them together. You can take them separately. You can cancel A and the A. You can cancel B and the B, right? Sometimes you cancel all two together. And hence, I think that girl's question just now, if AB is 1, the textbook gives you the impression, but it's two different symbols, right? Yeah. So because C is left, you put that in the bracket. So now what we have here, we have taken this and we have factorized it, right? Why do we call it factorize? Because we can say that AB is a factor of this whole expression, and A plus C is also a factor, right? Like, okay, you all know when you have our 6, what are the factors of 6? 2 and 3, right?
2 and 3.
Yes. So the factors of 6, 1 is also a factor, but we talk about prime factorization here, right?
1, sir.
Yeah. So 6 is the same as 2 by 3. So we have written 6 as a product of its factors. Now that's what we're doing here. A squared B plus ABC can be written as a product of its factors. And what are the factors of this whole long expression? They are AB and A plus C. Right? So when you talk about factorization, that's the process. However, before we go into more factorization, where did this come from? This whole approach where you take out the common factor, or you hear something called highest common factor, HCF, HCF, right? And you put it to the front, and then you divide the whole expression by that highest common factor. And you put whatever is the, what do you call it? The quotient, right? You put a quotient inside of the bracket. Don't worry the fancy word. Let's go to something to understand this factorization thing. Let's go to something called the distributive law. Distributive law. Distributive law. Right? Now, what the distributive law is saying is if you have A out here and you have B plus C here, this is equal to, and I'll put 3 strokes here. It means that it's identical to, not just equal to. It's identical to AB plus AC. In other words, the distributive law is saying that if you have an expression that is a product of 2 factors, you see, this is a factor, factor 1, and this here is another factor, factor 2. You could multiply this factor that is in front here by everything in the bracket. So we multiply A by B, and we get AB. Then we multiply A by C, and we get AC. Right? So the distributive law allows you to do that, to take 2 factors and multiply them and get this. It could work also if you have subtraction in the bracket. A bracket B minus C. That is equivalent to AB minus AC. You are multiplying what's in front here, the first factor, by the 2 expressions or terms in the second factor. You're doing that here. Tell me if you follow that.
Yes, sir.
Yeah, so you multiply what's in front by everything inside. This is a very useful tool when it comes to solving equations and so on, right? However, factorization is the opposite of the distributive law. It's the very opposite. You are taking this now and you're going that way. You're taking this and you're going this way. You are taking this sum and you are writing it as a product. You're taking this difference and you are writing it as a product. See? So watch here. You're looking for the common factor. The common factor is A. You pull that to the front. Bracket. AB divided by A is B. AC divided by this A is C. You see? So AB plus AC is equal to, I'm putting 3 stroke because it means equivalent. It's equivalent to, and here I factorize it. I look for the common factor. Common factor in this case is A. Pull it to the front and divide each term. AB divided by A will give you B. AC divided by A will give you C. Similarly here, AB minus AC is equivalent to A is common, you put it to the front. AB divided by A gives you B minus AC divided by A will give you C. So the distributive law helps you to take a factor, take two factors, multiply and give you a sum. It helps you to remove brackets. But factorization helps you to write the sum as a product and introduces the bracket. It's the very opposite.
Excuse me, sir.
Yeah.
It ever had a case like if that it have both same letters or whatever in case that you cannot factorize it is just a factor, like for instance it's like AB plus AB. It ever had a case like that?
All right, let me go to something we're talking about. So you're saying, okay, AB
Plus AB.
Plus AB?
It's like, yeah.
Well, in this case, you wouldn't factor it. You add it up and you get 2AB.
Okay, sir.
Introduce a bracket now, you know?
Yeah.
And then both A and B is common, so it wouldn't make sense. This is 2AB, right? What you will use it for is things like if you have, all right, 2A squared B plus, let's say, 3ABC. Let me use some nice number. Let me go with 4 here. 4. 4. We go with 4 minus BC. Right? Let's say you want to factorize this. Factorize. I'm going to look through here. What you see common?
ABC.
BC. Right? So, all right, let me put a number here now. Let me put a number like 2 here. Right? So we're seeing 2 is common, B is common, C is common. So we bring out 2BC bracket. That's divided. 2, no, there's no C here. There's no
Sorry,
C.
it's A, sir. It's A, not. Yes, sir, you have C.
There's no C on
C.
the fourth one. So C is not a common factor. So
It's
only
just B,
2B is
sir.
common, right? 2B. So 2A squared B divided by 2B will give us A squared, right? 4ABC will give us 2AC, right? Minus 2BC divided by 2B will give us C. And we close our bracket, and that's it.
Sorry, so you're basically looking for what is common in each and every term.
Yes, because you want to pull that to the front, correct? Let's do something a little more complicated. So look here.
Excuse me, sir.
Yeah.
So when you have to factorize the numbers, you have to divide them.
Yes, you have to divide. Yeah, correct.
Okay.
Let's say you have something like this. X squared plus 3x plus 2x plus 6. I have to factorize something like this. Right? So when you look, you almost have no common factor. Right? Do you see a common factor?
Oh, sir.
No. However, a technique that they employ is this. You take 2 at a time. So you take x squared plus 3x, right? Plus, and you take 2x plus 6. And you factorize them separately. So x is common here. So you have x into x squared gives you x. Somebody is asking whether you have to divide. Yes. X squared divided by x will give you x plus 3x divided by x will give you 3. Notice you have to do the division mentally. If you can't, write it in the corner here, you know? X squared divided by x will give you x. 3x divided by x will give you 3, and that's what we write in here, right? Plus, what's common here? 2. 2x divided by 2 will give you x, plus 6 divided by 2 will give you 3, and you get that, right? Now you're seeing something here. We still have a common factor. X plus 3 is here, and x plus 3 is there. So what we could do now, because those are common factors, we can pull them to the front. So we can pull 2x plus 3 here to the front, times what is in front of the thing here, x plus 2. Right? Just like, remember, if you have a times b plus, let me write that, yes. A times b plus, let me use this as b. Yeah, b times a, there you got a, b times a plus b times, not b, let me go, maybe c. C times a, right? So a and a is common, you put it to the front. And b and c goes in the next bracket. And that's a special technique that those who do algebra Fordham, there's something called quadratic equations. You'll have to know how to factorize to solve it. But I'm thinking whether it's in the course, I'll have to look. We'll do another one, Justin. Give me 1 second, let me see that in the course. No, I don't notice it. No, I don't. Yeah, I don't notice it inside of the course. Good. So that's a nice little introduction. You want us to do one more or so?
Yes, sir, please.
Yes, sir.
All right, let me do one. So if you have some ideas,
Sir, before you move, right?
uh,
At the bottom, we get x plus 2. Where did the 2 come from?
this x plus 2, this x here, and the 2 there. X here and the 2 there.
Okay.
Yep. Yeah. Let's go with another one. So we're going with, and this is more tricky now. All right, let me go with a simple one, then I'll go with a tricky one to close out. Right? I want you to have nightmares tonight with that tricky one. So let's say you have x squared plus 4x plus 3x plus 12. You're asked to factorize that. Again, you see there's no common factor throughout. However, if you group them, you get this. X squared plus 4x plus 3x plus 12. Right?
Can you use them out a little?
Say that again.
Can you zoom out a little?
I didn't hear that clearly.
The first part of the sums, I'm not seeing it clearly. I'm only seeing from the plus come back.
Oh, really? I don't know what to do. Tell me if you're seeing.
Yes, sir.
You seeing it now?
Yes, sir.
Sorry, don't work with me sums.
Yeah, good. So now your common factor here is x. Okay, pull that to the front. X squared divided by x will give you x plus 4x divided by x will give you 4 plus what's common here? 3, right?
3, sir.
3 into 3x will give us x. 12 divided by 3 will give us
4.
Now, what we see here is that x plus 4 is common in both terms, right? Both terms, that x plus 4. So we can now pull that. Let me see if I can take it up somewhere. Yeah. We can pull that x plus 4 to the front. And somebody is asking, what do we put here in the next bracket? We put what's in front of x plus 4.
X plus 3.
X plus 3. So here you were able to write this very complicated thing that has 4 terms, right? You still have 4 terms, x plus 4 and x plus 3, but it's a product of 2 pairs of terms. You have written this sum as a product, something multiplied by something. I want to do one last one that is a little difficult, tricky. One last. Let's go with, you have to factorize x squared plus 4x minus 3x. Let's say minus 12. You have to factorize that. So, okay, let's try and see. Let's say you take these two together. You get x squared plus 4x. Put that in one bracket. Now, if you are tempted to put plus here, what do I put in these two brackets? What do I put here?
Negative.
Or what do you want me to put here? Do you want a plus sign there or a minus sign?
Minus.
Minus.
All right, okay. So let's go with a minus sign, right? So let's say I put a minus sign here. Minus. So, okay, minus 3x. What do I put here now in front of the 20? Do I put a minus there?
No, sorry.
Yes.
You're coming.
Now, if you were to put a minus here and you were to remove this bracket, you would have, watch, minus 1. Minus 1 by this 3x will give us a minus 3x. But minus 1 by this minus 12 will give us positive 12. So when we do the reverse, we're not getting back the same thing. And therefore, it will be wrong for us to put a minus sign there. Right? We have to change the sign to a plus. Right? So if we choose to put a minus sign outside here, you have to change this sign here. Right? And then you proceed from there. But I'll show you some alternatives to avoid that. Right? Good. So let me go. Let me finish this one. So you take x is common, get x plus 4. Take out here 3, so you have x plus 4, because you want these two brackets to be the same. If they're different, it wouldn't work. Right? So you want these two to be the same. So you put x plus 4, bracket x minus 3. Right? That's one way. If you want to avoid this problem here, and you might end up, if you think you're going to be tricked and you wouldn't know what to put in there, this is what you could do. You go from here, you go x squared plus 4x. Put a plus sign, what is here? Put a plus sign in this bracket, put minus 3x minus 12. Right? Then do your factorization. X bracket x plus 4. Down here, take out minus 3. Right? Take out minus 3. So if you want to put a plus, no problem. Minus 3. So minus 3x divided by minus 3 will give us x. Minus 12 divided by minus 3 give you positive 4. Right? So this plus sign and this minus sign will become a minus. Plus by a minus is a minus, right? And then you bring the common factor to the front times what's here and here, x minus 3. Same answer. There's another approach too that can help you. Another approach. If you're having trouble with this is what you could do. Take this expression here, I'll write it back, right? Let me write it. X squared plus 4x minus 3x minus 12, right? And if this is going to be a problem, write this the other way around. Write that this way. X squared minus 3x plus 4x minus 12. And then group them up together. So you're not putting too many minuses together. So now you get x into that. They give you x minus 3 plus 4 into x minus 3. Right? Pull this to the front, so you get x minus 3 times x plus 4. In the previous ones, our answers were x plus 4 times x minus 3. But these two things are the same thing. Here you have x minus 3 in front and x plus 4 in the back. Here you have x plus 4 and then x minus 3. This is like 2 multiplied by 3 is the same as 3 multiplied by 2. So your answer is still correct.
Sir, to me, the first one is more better than the other two.
You make your choice, right? One last thing before we leave. How do we take this though and get back that? Right? Let me just show you that. So let's say you have x plus 4 multiplied by x minus 3, right? Two ways you can do it. You apply the distributive law. Whatever is in here, multiply by each of these, right? So you can say, okay, if x times x plus 4 minus 3 times x plus 4, which is equal to x squared plus the distributive law, right? X by x gives us x squared. X by 4 gives us 4x. Minus 3 by x gives us minus 3x. Minus 3 by 4 gives us minus 12. And if you look carefully, this can even be simplified further, right? You can get x squared plus 4, plus x minus 12. But this is what we had originally. But it can be simplified to this. Alternative is this. Let me go here. X plus 4, x minus 2. What you could do is a shortcut. X multiplied by x gives us x squared. X multiplied by minus 3 gives us minus 3x. 4 multiplied by x gives us 4x. 4 multiplied by minus 3 gives us minus 12. Right? So this is the same as that, even though the minus 3x is in front. If you simplify it, you get x squared. Minus 3 and 4 will give us positive x, right? Minus 3x and 4x will give us positive x minus the 12. It's not in the course outline, but I'm just showing you, you know? Good. So we'll stop here, right? You already know. It's quite a bit for one evening.
Sir.